Hey folks, welcome back. In this video we're going to go over two worked examples to show you how to do problems involving phase and coherence. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says, to investigate the interference of sound waves, a student connects a signal generator to two identical loudspeakers, as shown below. A microphone is used to detect the interference pattern. So you can see the SIG-Gen connected to two loudspeakers. We've then got a microphone connected to an oscilloscope, and the microphone can be used to detect the interference pattern. Part A says the two sources of sound waves are said to be coherent. What does this mean? Well, remember from the notes, it means that the waves from the two sources have a constant phase relationship, and therefore have the same frequency, wavelength, and velocity. Part B then says loudspeaker 2 is now connected to a different signal generator which produces sound waves of a different frequency to those from loudspeaker 1. Are the two sources still coherent? Explain your answer. Well, we could say that no, the waves from the two sources are no longer coherent. This is because the waves now have different frequencies. Question 2a says to describe how constructive interference arises between two waves. Well, remember, constructive interference occurs when two waves of equal amplitude meet in phase, i.e. when the crest of one wave meets the crest of another, or the trough of one wave meets the trough of another. We say that the waves combine to form a wave of twice the amplitude, and it looks something like this. So if you add one wave to another where you've got the crests matching up and the troughs matching up, then you end up with a wave of twice the amplitude. Part B says to describe how destructive interference arises between two waves. Well, remember, destructive interference occurs when two waves of equal amplitude meet out of phase, i.e. when the crest of one wave meets the trough of another. The two waves cancel out to give a wave of zero amplitude and therefore zero energy, and it would look something like this. So if you have one wave overlapping another where the crest meets the trough, or the trough here meets the crest here and so on, then you'd end up with a wave of zero amplitude. And lastly, part C says to explain why it is not possible to obtain interference from two light sources. Well, remember, this is due to the random nature of photon emission for light. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.